Now we will start with chapter number 4, which the topic is Cisco software. Cisco software defined access fundamentals. This chapter has 1, 2, 3, 4, 5, 6, 7, 8 subtopics. The first is network topologies. The second, Cisco software defined access underlay. The third, wireless LAN controllers and access points in Cisco software defined access, shared service, transit networks, fabric creation, fabric device roles, host onboarding. So starting with network topology, we know that normally when we talk about topology, especially for the campus, we use the three-layer topology. Three-layer topology, which is composed by the core, which handle the communication with the external network. Then we have the distribution, and next we have the access, which is the layer that is more connected or directly connected to the users. There is some difference between these topologies and the fabric, because in the fabric we have different terminology that we are going to talk a little bit further. Next, we have Cisco software defined access underlay. What is the underlay? We have to know that there is two layers. There is the underlay and there is the overlay. The underlay is in the bottom. It's the network that supports the overlay. It is composed by different devices, and what we want to have in the underlay is fast communication. The devices must be reachable. It can be used at different routing, like static routings and dynamic routings, but the communication must be fast in order to underlay to be built over the underlay. So on the underlay we have switches, we have routers, but it is just the base, what we don't see but have an important hole inside the fabric. Wireless LAN controllers and access points in Cisco software defined access. In Cisco software defined access, we still have in the WLC, that is the wireless LAN controllers. Normally they are out of the fabric, but they allow the access points to be inside the fabric. Normally we have the access points, and the access points are able to build a tunnel to the wireless LAN controllers. And this tunnel is normally the CAPWAP that allows the wireless LAN controller to manage the access points that are inside the fabric. Shared services. There is some service that must be available in the network, common service like the DNS, like the DHCP, like the NTP, and many others. These services normally they are also out of the fabric because they are in the data center, and we know the fabric is just the campus. It's composed by different nodes. The transit networks is what allows us communication with outside of the network. And this transit network it can be built in two ways. It can be IP based transit, and also the SD access transit. Here we configure the parameters, we get into the devices, and we must configure the reachability between our fabric with the outside of the network. And with SD access, the devices can be configured automatically, normally using the LAN automation. And this LAN automation, it's very important because inside the LAN automation that is available on the SD access, we can have a blank switch and connect it to a seed switch. We have a seed switch, a switch that exists already in the catalyst center, the seed, and we can have a blank switch as long that it have reachability with with the switch that is the seed. It can download, it can have the integration and to be part of our network. So we can use it in this way, and it will facilitate the integration inside the catalyst center. Normally this switch, it can use the PNP, which is the plug and play. That is the protocol that allows it to be fastly integrated. Then we have the fabric creation. There is some things that we must take in consideration when we are doing the fabric creation. The first thing is the fabric location. You know that we talked it in the last chapter that normally when we create a fabric, we must do a design of our network. It must be a hierarchical network. So we must define what is the location of our fabric. Then we have the fabric virtual networks, where we can define the scopes of our network. And then we have the fabric roles. So we define the location, we define the virtual networks, and the virtual networks normally is associated with the VRF or also the VLAN. We can have a virtual network layer 3. Layer 3 is like a VRF, and the layer 2 is like a VLAN. Normally we associate these virtual networks also with the IP pools. What is the range of the IP pools that should be available inside our fabric? Talking a little bit further about the fabric device roles, there are some roles that are essential that we talked last time, like the edge node, like the border node, and like the control node. Edge node is what permit the users to have access to the network. The border allows us to have access with the external network. It can be internal border node, or also an external border node. What is the difference between them? The internal border node, it allows to have communication between our fabric and some devices that are not part of the fabric, but they are from our network. It's like our network but outside of the fabric. With communication with these networks is done with our internal border nodes. And you can think like the data centers. The data center are not part of the fabric, but they are important for us. And the external network is like the internet. It allows to have the default gateways, so whenever we don't know where to send the traffic or where is located this traffic, we can send it to the external border node to have with communication with our internet. And we have the control node. that allows us to have the information about all the infra. Whenever a switch doesn't know where to send the traffic, it must to have to communicate with the control node. It is like we talked the last chapters. It uses the Lisp to know the exact location and how to route the traffic inside the fabric. There is also some specific devices that we can talk, like the fusion router. With the communication between the fabric and the external networks can be done using the fusion routers. There is sometimes that we have like our external network is part of the company. Like, let's talk about the DC, and here we have our fabric. Okay, in the here we have like our border node. The communication with the other network can be done directly from the border node to the external network, or we can use an intermediary device like a fusion router to allow this communication. Here we have our VNs associated to the VRF. We also create here the VNs, or the VRF in this case, to allow the communication with the border node. We can have here some different static routes or dynamic routes like BGP, eBGP, and then it can convert it to our global routing table to be sent outside. The other way is to have a direct communication with the border nodes. You just need to know how to deal with the VRF and the routing protocols in order to do this setup. For the ones that doesn't know how to do this setup, they can utilize an intermediary device like a fabric router to have this working. And lastly, we have the host onboarding. When the device is already in the network, it can use closed authentication or open authentication. We can define exactly what is associated to each port of our router. You can overwrite the configuration, and this is done inside the host onboarding. So this is what is bordered inside the chapter number 4, Cisco Software Defined Access Fundamentals. So this is the fundamentals, and then in the next chapter we are going to go deep inside of these subjects.